not match. So the easiest system is when you have matching coefficients, and the system requiring a little bit more work is when the coefficients are not matched up at all. So you simply look at, analyze the equations as they're given, and you decide which variable you would like to eliminate first. So in this video, I'm going to go with eliminating y first. I'm just making a choice to eliminate y. There's no right or wrong answer. So what I'm going to do, if I can give each y term a coefficient of 10, then I could add the two equations together and eliminate the y variable temporarily. So what I need to do is figure out what each term should be multiplied by in order to give it a coefficient of 10. And in the first equation, I would need to multiply each term by positive 2. So each term in the equation would be multiplied by positive 2. So my new system, my new first equation looks like this. And now the second equation, in order for y to have a coefficient of 10, I would need to multiply each term by 5. So in blue, equation number 2 now becomes this. So this becomes my new system. Simply multiples of the original system. And now, if I add, I've got my columns all lined up, everybody's in standard form, and if I simply add the two equations together, I'll put my addition symbol here. If I add them together, then I'll temporarily eliminate y. And doing that, I have 33x, 10y plus negative 10y, zeroes out the y, and that equals 99. And it's not necessary for you to put a holder there with a 0y, but I'll do it in this video just for teaching purposes. But really, this is what's left over. And it's easy to see that x equals positive 3. So now I have to find the y value. And I'm just going to go back to the original equation, the first equation, but you could go back to either the manipulated blue or red equation or either original equation in black, substituting in your x value, and that would allow you to find y. It should work in any. But I'm going to use the first equation. And in place of x, I will substitute in the number positive 3. So the solution for this system is the ordered pair, positive 3, positive 7. And I will leave the check to you. You can go back to either in any of the equations and substitute in the x and y values that we solved for, and it should all work out. It should give you a true statement. Okay, so here the coefficients don't match and the equations are not lined up. So before you can do anything, you need to rearrange the equations so that it's in standard form. So here are my equations. And I would need to bring this negative 6x over to the other side. And now I can analyze my system. And in this particular system, in the video, I'm going to choose to eliminate the x. And the reason I chose to eliminate x, if I can give the x right here a coefficient of positive 6, then I don't have to do anything to the second equation. So I've cut down on my workload as well as cut down on my the possibility that I could make a mistake in my calculations. So try to find the most efficient method for working. So I'm going to take the first equation, and I need to multiply each term in the first equation by positive 3. So this is my system. And now here's my new first equation. I'll do it in red. And now I have 6x minus 21y equaling 123. And then I'll just simply recopy the second equation in black as it was above. if I subtract the second equation from the first equation, or I could take the second equation and multiply each term by -1. You can do that if you want to. And subtracting my columns, the x variable is eliminated, and I'm left with -26y equaling 130. So I can see that y equals -5. And now I have to find the x value. And I simply went back to the original first equation. And in place of y, we'll put in the number -5. And I can see that the solution to this system is the ordered pair, +3, -5.